Hi! Panibagong araw na naman para sa ating bagong paksa ng matematika ang ating pag-aaralan. Scalar and vector projections. Before vector projection, we have to look at scalar projection, or generally we say projection of B on A, means vector B produces projection on vector A. Projections are basically of two types. We have scalar projection, which tells us about the magnitude of the projection, and vector projection, which tells us about itself and the unit vector of the projections. So, we have these illustrations. In equation 39.1, the scalar A sub 1 is called the scalar projection of A on any vector whose direction is that of the positive x-axis. While the vector A sub 1 I is called the vector projection of A on any vector whose direction is that of the positive x-axis. In general, for any non-zero vector B, any vector E, we define A dot B over the magnitude of B to be the scalar projection of A on B. And we have A dot B over the magnitude of B and B over the magnitude of B to be the vector projection of A and B. Note that when B has the direction of the positive x-axis, B over the magnitude of B is equal to I. So, the property of 39.15 A that B is the product of the length of A and the scalar projection of B on A. Likewise, A dot B is the product of the length of B and the scalar of A on B. So, scalar projections. Scalar projections tells us about the magnitude of the projection. Recall that the dot product of a vector is a scalar quantity, describing only the magnitude of a particular vector. A scalar projection is given by the dot product of a vector with a unit vector of that direction. So, we have this formula for scalar projection. Projection of A on B is equal to A dot B over the magnitude of B. Or similarly, we have projection of B on A is equal to A dot B over the magnitude of B. And we have for vector projection, the indicate red vector is called projection of A onto B. When you read as projection of A onto B, you should say the vector projection of A onto B. As the vector projection formula is defined as the product of scalar projection of A on B and the unit vector along B. So, we have vector projection of A on B is equal to A dot B over the magnitude of B, and B over the magnitude of B is equal to A dot B and B over the magnitude of B squared. Or similarly, we have vector projection of B on A is equal to A dot B over magnitude of B, and we have A over the magnitude of A. And we have A dot B and A over the magnitude of A squared. For that, we have example number 1. So, for example number 1, find the scalar projection of vector A or vector V is equal to 3 and 4 onto vector B or vector U is equal to 5 and negative 12. As the solution, as noted earlier, the scalar projection is the magnitude of the vector projection. This was shown to be A that B over the magnitude of B, or U that B over the magnitude of U, where U is the vector being projected onto. So, we have U that we have the formula which is U that V over the U squared. That would be squared. I know. Is it not squared for scalar projection? Then next, we're just going to substitute the value. So we have the value for U, we have 5 and negative 12, and for V, we have 3 and 4. So it could be 5 and negative 12, that 3 and 4. In order to get the denominator, we just need to square root the value of U, which is the first one, which is the 5. So 5 squared, we get 25. Then 25 minus 12, we can get 13, and that would be our denominator for the magnitude value of U. And now we're just going to multiply it. So we have 5 times 3, we have 15, and negative 12 times 4, we got 48, and copy the denominator and equal to 15 minus 48 is equal to negative 33, and copy the denominator, and we get negative 33 over 13, and that would be the scalar projection of vector B onto vector U. And for the next one, for example number 2, if A is equal to 7i plus j minus 4k, and B is equal to 2i and 6j and 3k, then find the projection of A on B vector. So, as the solution, here we have the value for A and B. So, as the formula for finding the projection of A and B vector, we have this one in the left side. So, as the solution, we have projection of A on B is equal to the quantity of, we just need to substitute the value for A and B. So, for A, we have 7i plus j minus 4k, that quantity of 2i plus 6j plus 3k over the magnitude of 2i plus 6j plus 3k. So, we just need to multiply this one as what like for scalar projection, but they have different methods in solving for the magnitude. So 7 times 2, we have 14, and j plus times 16, we have times 6 rather, we have 6. It because for j, it cannot be 0, because it has a value for j as 1, as imaginary 1. So 1 times 6j is equal to 6, positive 6. And for negative 4k and times 3k, we have negative 12. So 14 plus 6 minus 12 is equal to 8 over